Hi, Dr. Kaminsky. I have a question.
Sure.
So before I logged out, um, I think it was Vanessa asked a question relating to the quiz.
Yeah.
That was it. I didn't know what was your answer towards that because
What did she ask?
I
What
didn't.
about the quiz?
I
The
mean, relating that is it open book just like
oh
that?
yeah, I mean technically, yeah, obviously you can have your notes out, but
Okay.
it's going to be a time limit, right? There's like a 10-minute time limit. Um, or I forget what it is based on the number of questions. So you don't have a lot of time to look things up. So like if you have some good notes next to you and you can just, if you like kind of forget something, just like look quickly, that's fine. But it's not like you're going to have time to, shuffle through the textbook or through your notes. So it's really,
Okay.
so yes, the
And
answer
also,
is, yeah, go ahead.
and also about the format of it, is it more of a multiple essay
All
type
multiple
question
choice. Yeah,
or
it's just
multiple?
all multiple choice. Yeah, the quizzes are
Okay.
always all multiple choice. Yep.
Thank you very
So
much.
yep, you'll know your grade right away.
Absolutely.
Okay. All right. So I'm recording, guys, and I know there's some of you guys that have class, so let me get going. So those of you that have to go to class at 2:30, feel free to just log off whenever you need to go. And so I just don't want you guys thinking you have to like hang out longer. We'll probably will only be about a half an hour, but I think I stayed on a little bit longer, just to kind of help out a few students and just clarify some things. So like I said, feel free to log off whenever you need to. Okay. So am I sharing my screen? You guys see my screen? Yeah.
Yeah.
All right, so let me just, so from Moodle, where we're at right now, and I kind of showed you guys this in the beginning of class, not there. Okay, so this is the first week that we have lab, so I kind of try to keep it separated by this little, icon here. So this is a super short assignment, and it's just straightforward metric conversions. Okay, so let me tell you, and I'm going to pull up a whiteboard and kind of do examples out. That's what I usually do in class anyway. And I will tell you that there's probably going to be some of you who are really uncomfortable with this. You haven't really been exposed to it too much, and that's okay. Okay, it's not meant for you to be like an expert in doing these. It's just a matter of getting exposure. So when you guys take your lab exam, there will be a couple of questions on this, but it's not going to be like the whole exam is on this. Okay, so don't get frustrated. Just do what you can. Know also that there are other resources out there. So like you can use Khan Academy, metric conversions. There's lots of little practice things that you guys can find if you need it. Okay. If you still need more, you can ask Katie about it at group tutoring. You can ask me to go over this again with you as well. Okay. So like I said, some people have had this, are really good with this, right? And they don't even probably need me to tell them anything. Okay. So that's just the way it is. So anyway, for your assignment, it's right here. So you're going to click on this assignment, and what you'll see when you click on that, just because I don't need to download it for the 15th time that I did. I always do that. I forget that I downloaded it. So I have like 18 downloads of the same thing. But what you'll see within the assignment, this file is there. It's also in that folder too. So this folder here, hello. This folder that says metric conversions practice, it's the same file. It's just a PDF, the same PDF. So you can click on it here, you'll find it. You can also find it within the assignment. So you're gonna submit those completed practice problems through this assignment here. And it is due Friday by 11:59 p.m. Okay?
You write on it?
Assignment.
Yeah, so here's the thing, you can. So if you want to handwrite on it and then just submit a picture of it, I'm okay for this assignment because all it is just doing these practice problems. You also can use a software called Kami. I don't know if anyone's ever used this. K-A. I actually learned this from my daughter.
It's not an app, right? Because I tried downloading it.
Yeah, but you can do it. You can get it from your computer. I guess it's not a software, it's just an app, but it's free. So what it'll allow you to do is actually to write in the PDF. So without having to have like Adobe Pro or something like that, and then it'll let you save that completed file, and then you can submit that. So if you kind of find that easy, you can do that as well. Like I said, you can also handwrite these, or you can retype them on a Word document and submit it that way. So however the heck you want to submit it, as long as I can see it, we're good. Okay. All right. So with that said, let me erase my Cami, and then we'll go from there. So like I said, so for this week, this is all it is. It's just to do these problems. Okay. Next week, again, I'll introduce that lab. Let me get this off of here. Sorry. I'll introduce that lab, you know, as well separately. And there's also a video basically of me introducing the lab, and doing the actual lab, okay? And explaining what exactly you guys need to do with that. Within that lab, there is some more metric conversions, okay? So you get a little more practice with it next week as well. So I'll put that out there too. All right, so what this PDF, and again, if you, I just quickly actually, even right now, just Googled metric conversions, you'll find other things like this, other tables that kind of represent the units this way. So this isn't really, to be honest, this is kind of just showing you, and I'm going to explain it anyway, just kind of a little trick in terms of doing conversions. But let's write out, and I guess I could just write right on here rather than kind of having to switch to a whiteboard. But if we're going to kind of write out, and again, these are also in the lab for next week. If you click on that PDF that says metric and microscope lab, there's a table that's there that outlines some of these, that outlines these units as well, okay? But we can just kind of start. So right off the bat, I'll ask somebody to tell me what's the metric system, or why do we use the metric system in science? What do you think? Why don't we measure stuff in inches and feet and I don't know, and pounds in the lab?
Because it's dangerous. You can't put more than what it is or less than what it is asking you for, because something else can happen.
Okay, more of, so think about the difference of weighing, so what's the difference of weighing something in grams versus weighing something in pounds? Why do you think in the lab we would want to weigh something in grams?
I think it's like the precise weight, I guess.
The volume.
Okay, I mean, so the metric system is a little more precise, and there's a lot of standard kind of conversions that you can kind of use, and we're going to go over that. But also it's universal, right? So like every other country, they use the metric system. And so if we're in the lab and we're like publishing research, we would want to have a standard set of units, right? And so that's really the reason. Like I said, it's a little more exact or precise as well. Okay, so what are some units? So if we talk about units of length, metric units of length, what do you think about for length? How do we measure things in length in the metric system?
Centimeters?
Yeah, so centimeter, right? Good. Meters. What else? If you get larger than a meter?
Inches.
Millimeters?
Say it again.
Foot? Millimeters?
Okay, so that's going this way. So I'm going left here. It's going to be smaller, and this is larger. So we kind of we'll consider meters as sort of our standard unit or our base unit. And so, yeah, so we go centimeters, that's smaller than somebody just said it. What's smaller than a centimeter?
Millimeter.
Yeah, a millimeter. What else? What about smaller? Oops. Okay. What about smaller than a millimeter? Micrometer? Ever hear that? Micron or micrometer? And then you can even go even smaller, nanometer. Okay? So for for the most part, especially for us in lab, we mostly will be using like millimeters, centimeters, and meters. We're not going to really be talking about kilometers, but you could talk about kilometers like if you're a runner, right? If we're talking about running distances or obviously, I don't know, measuring speed or something like that, right? So anyway, what we want to be able to do though is to convert our units, right? So if we say that something is 1 meter, okay, we want to be able to know how many millimeters that is, right? Or how many centimeters that is. And then be able to, again, convert either way, any way, okay, any which way. So I'll ask you this, the difference between, so we're going to talk about like factors. Okay, so the difference between millimeters to meters, what factor is it? Is it 100? Is it 10? What is it? So in 1 meter, I'll ask it this way. It's equal to how many, oops, let me get it away. How many millimeters? How many millimeters are in a meter? Millimeters in a meter, you think?
1,000.
Correct, 1,000. Okay. All right. So now let's think about a centimeter. So in 1 meter,
100.
is equal to 100 centimeters. Okay, so centi 100. Now, so for the most part, okay, these units differ by a factor of 1,000, okay, with the exception of centimeters that's thrown in here and then kind of going from centimeters to millimeters. So if we said that there are 100 centimeters in a meter, right, we said there's 1,000 millimeters in a meter. How many millimeters are there in a centimeter?
1,000.
1 centimeter equals how many millimeters? So we're only here. So it's not going to differ by 1,000. So this is the only kind of exception. 10. Okay. And when you do the lab, next week's lab, this will get more clear because we're talking about measuring things with a little ruler that has millimeter measurements and centimeter measurements, and then converting back from millimeters to centimeters. So there are 10 millimeters in 1 centimeter. There are 100 centimeters in a meter. There's 1,000 millimeters in a meter. Now, everything else always differs by a factor of 1,000, okay? So if you go from like millimeters to microns, it's 1,000. So there are 1,000 microns in 1 millimeter, okay? So, and again, just like there are 1,000 millimeters in 1 meter. Okay, like I said, the centimeters kind of throws things off, but in actuality, you know, the reason why we break that down further, because there's a lot of things that we measure that are between millimeters and a meter. And so the centimeter is a very useful unit of measurement. Okay. All right. So we said, so don't worry, there's
Guess
more.
what?
Go ahead. Anyone have a question right now? So what about weight? What are some units of weight, metric units of weight? I think I said it already before.
Gram, kilogram.
Pounds, ounces.
No, those are all no, those are not metric units. And so you can see how it's confusing already if you think about ounces and pints and
Gram.
and 18,000 different things. Yeah, gram. So what about larger than a gram?
Kilogram.
Kilogram. What about smaller than a gram?
Milligram.
Yep, milligram. We usually don't use centigram for whatever reason. So like I said, this is kind of the only place where we really will use centigram a lot. What about smaller than a milligram? Same thing as up there for the distance.
Microgram.
Units. Microgram. Okay, so all of these will differ by a factor of 1,000. Okay, so each time you're going from one unit to another, right? So I'll ask you this. If we say, and then I'm going to go the other way with you. So if we say 1 gram, right? It's equal to how many milligrams? It's not a trick question.
1,000.
1,000, correct. Okay. If you go the other way, right? And you say, all right, well, what about 1 milligram? How many grams are in 1 milligram? So now we're going the other way, right? We're starting with a smaller unit and then moving to a larger unit. So here, when we were starting with a larger unit and moving to a smaller unit, what did we do? We always moved the decimal place to the right. Do you guys agree? And it's 3 places because it's 1,000. Okay, that's what this text is explaining to you. Okay, so if you're starting with a larger unit and going to a smaller unit, you will always move that decimal place to the right based on whatever the factor is. And so if we're talking about 1,000, it's 3 decimal places to the right. So do you agree your decimal place would be here? You're going 1, 2, 3, and you end up with 1,000. Okay?
So would it be 0.001 grams?
It certainly would be. Thank you. So if you're going the other way, here's your decimal place. Now you have to go 3 places to the left and the unit gets smaller, okay? Now I like to kind of give this analogy, and I don't know, you can think it's useful or not. But if you kind of think of the units like this, right? Here's your gram, and then here's your milligram over here, right? Right? This is a smaller unit, this is a larger unit. So if we're talking about, you know, how many milligrams can fit into a gram, there a lot can, right? Like 1,000. Obviously that's not drawn to scale. If you go the other way and now you're asking, well, how many grams can fit into a milligram? It's a fraction of that gram, right? So the number has to get smaller. So I don't know if that helps. I feel like that's a little kind of something that helps conceptually to think about. Okay, so whenever you're starting with a larger unit and you're moving to a smaller unit, the number is going to get bigger. Your decimal places will always move to the right. If you're starting with a smaller unit and moving to a larger unit, decimal places move to the left. Essentially, you're either multiplying by the factor or dividing, okay? Now, in chemistry, you might always have to write out like dimensional analysis. That's fine. You could do that like that. This is kind of a shorthand way of doing the conversions, right? So like what I mean by that is kind of like, you could say, I don't know, right? You have 1 gram is equal to 1,000 milligrams, right? And then you're gonna, I don't know, you're basically gonna write your factor here in terms of how many milligrams, and then you're gonna cross divide to figure out what that is. So you can kind of write that out, meaning like you're multiplying by 1,000 or dividing, but moving the decimal place is the same difference, right? It's the same thing, okay? So honestly, if you know how to do these and you do them and you write them out the long way, or you're thinking about multiplying and dividing rather than moving decimal places, that's fine. I don't care what you do, okay? The other thing to take to mention is that, you know, sometimes we talk about scientific notation. Do you guys agree? So for 1,000, what would that be in scientific notation? 10 to the third, right? So like you could write out 1,000 as 1 times 10 to the third. Because I say that because what if I asked you 1 gram is equal to how many micrograms? What would be your answer there now if we're talking about micrograms? Sorry for that terrible handwriting there. How many micrograms? Is it 1,000? No, right? It's another 1,000 on top of that. So it's 1,000 times 1,000. So you're talking about moving how many decimal places? 6 decimal places, right? So it would be 1,000,000 there, or 1 times 10 to the 6th. So sometimes it's useful to use scientific notation, but I don't really care. Write out the zeros, whatever you need to do, okay? It's about understanding the concept. All right, so if you guys look down here, so questions. I'm gonna give you guys some more practice or trial problems here. No questions right now? All right. Okay, so if we, oh wait, let me just see something. Let's look down here in terms of what's here. Oh, let me erase that. Never mind, I need to erase that first. Hello, sorry. Let me just erase that because I'm gonna get in our way. And we'll do some more examples. Okay, all right, so if we move down here, you know, this is basically just showing you, you know, 532 meters is equal to 0.532 kilometers, right? Why? Because meters is a smaller unit. Well, so we can go this way. Let's go this way. We're starting with the larger unit, right? Moving to a smaller unit. So what do? We move our decimal place to the right, right? It's getting larger. So it's the 3 places because we're talking about a difference of 1,000, right? If we go from meters to centimeters, remember that it's only a factor of 100. Okay, so you're adding 2 zeros there, and so that's why we're at that there. So these are all examples here in terms of kind of what we just went over, right? So again, if you go from millimeters all the way down to nanometers, right? This is 1,000, and then it's another 1,000. okay? So you have to make sure you know, and I shouldn't probably have erased that one thing that I had. Remember I showed you meters and then centimeters, right? Millimeters, micrometers, and nanometers. Each one, remember, is going to differ by that specific factor, which is usually 1,000. All right, so let's do a couple, I guess, conversions. And again, remember, it's the same thing with mass, right? Going from grams to kilograms to milligrams, and also with volume. So what do we use to measure volume? Metric system for volume.
Liters, milliliters.
Yep, liters, milliliters, microliters. Okay, for the most part. All right, and those are probably the three main units that we would use in the lab: liters, milliliters, microliters. Okay, usually don't get smaller than that. All right, so let's do some more practice problems. Okay, so again, it doesn't matter if we're talking about length, we're talking about mass, or we're talking about volume. The way that we're going to do the conversions is the same. Okay, and again, most of these units will differ by a factor of 1,000, with the exception when we're talking about centimeters. Okay, that kind of gets thrown in there. But again, the reason why we mention that is because we use that unit a lot, because there are a lot of things that measure or are that size. Okay, all right, so let's see. All right, so what do we want here? Let's see. Let's do, all right, you have something that is 40 grams, okay? And I want to know what that is equivalent to in kilograms. So if we go by this sort of shorthand way, we want to say, all right, this is which one's larger and which one's smaller. So grams is a smaller unit. You guys agree? And we're moving to kilograms, which is the larger unit, okay? So in that case, our decimal place is starting off here. Which way do we want to move it?
Would it be 0.04?
Left.
Correct. Left. And yes, you're right. We want to go 3 decimal places to the left, right? 1, 2, 3. So we got to add a 0 in there. So it's 0.040. Okay. All right. So let's do the
I have a question. Will we actually have to add the extra 0 at the end?
Yeah, because you're going 3 decimal places, right?
Okay.
All right, so let's do another one. Okay, so say I said you had something that is, oh, we probably want to go to larger. Okay, so we're going to say it's 50 liters, okay? But we want to know what that is in milliliters. So now we have a larger unit here, a smaller unit here, okay? Our decimal place starts here. Which way do we want to move that?
The right.
To the right.
To the right, right? And we have to go 3 places to the right. So we got to add zeros each time we move to the right there. So 1, 2, 3, we're adding 3 zeros. So what am I writing here? 50, it's terrible, 50,000. Okay? Got it? Now, what if I said though, we have 50 liters, okay? But we want to know what that is in microliters. It's not a factor of 1,000, right? It's going to be 1,000 times 1,000. So sometimes you might have to kind of jump to another sort of unit. So in that case, we're going to add how many zeros here?
6.
6, correct. So like I said, if you want to write it out longhand, I don't really care. And usually I don't really give you conversions like this anyway, because it's not really something that we would do in the lab. But it would be this. It's 6. Because from liters to milliliters is 3 zeros, right? Is 1,000. And then from milliliters to microliters is another 1,000. How would you write this in scientific notation, guys?
5 times 10 to the power of 6.
Correct. 5 times 10 to the power of 6. Okay. I'm not going to ever I don't really care about that. For me, I just care about understanding how to do it in concept. So if you write out these zeros, all right, should we be able to recognize that's the same thing as 5 times 10 to the 6? Yeah, but I'm not like concerned about significant figures and like scientific notation. You do that in chemistry a little bit more. So I really just want you guys to understand the conversions and how to do them. Okay. All right, let me give you another one. All right, so something measures let's try that again, 3.2 centimeters, okay? What's that in millimeters? Now remember, now we're not talking about factors of 1,000 now, right? Our factor is a little bit different. So let's think about that in terms of, well, we can just do it the same way. Let's do it the same way we were. Is centimeters larger or smaller than millimeters?
Larger.
Larger.
Correct. Centimeters is the larger unit, and we're going to millimeters. Therefore, we're going to have to move our decimal place to the right. Do you guys agree? The number is going to get bigger, right? Okay. So how many decimal places do we move it, though, in this case?
2.
Why'd you say 2?
Because it's centimeters to millimeters, and centimeters is only 100 instead of 1,000.
But centimeters, there are 100 centimeters in a meter, right? So if let's go backwards. If we talk about millimeters, right? There are 1,000 millimeters in a meter, right? But there's only 100 centimeters in a meter. So we're really left with a factor of 10. So
We're only moving it once.
yeah, so easier to think about, there are 10 millimeters in 1 centimeter, right? So we only move it once. It's only a factor of 10. So what do we put here then?
32.
32. Okay, so again, the point is we have to always remember that it's not always a factor of 1,000. Okay, we also have to be careful that if we're, like my last example where like I asked you to go from liters to microliters, not just liters to milliliters, right? So it's a factor of 1,000, but it's twice because we're going even smaller. All right, let me give you another example. What we got here? I don't know. All right, let's do this. 450 milligrams is equal to how many grams? So our decimal place is here. Our milligrams is a smaller unit, grams is larger, right? So which way do we need to move our decimal place if we're going from a smaller unit to a larger unit?
To the right.
Right. If we're starting with smaller, right, and going to larger.
Left.
Left.
To the left, right? Because the number, so remember what I did here? Remember we did this, right? Here's grams, here's milligrams. So if we're starting with this smaller unit and we want to know how many we have of the bigger unit, only a fraction of that bigger unit can fit in there. The number's going to get smaller. So in this case, how many decimal places would we move it?
3.
3. What?
3, right? Milligrams to grams, factor of 1,000. The only time it's not going to be a factor of 1,000 is when we're talking about centimeters and millimeters. Okay. I mean, well, really the centimeters throws that in there. It's just, but it's nothing different. It's just that we added in an extra unit in between millimeters and meters. Okay. So it's, I don't know. I don't want to like confuse you more, but for that's the only kind of exception for our purposes right now. All right. So what would be our answer here? Point what? 450, right? Oh, by the way, like if you wrote 0.45 and didn't add the 0, I don't care. Okay. I know some people care. I don't really care. Like I don't, like I told you, I don't really care about significant figures. I'm not going to be like only put 2 significant figures or 3 significant figures. That's not of concern to me. I just want to know that you know how to do this. All right. Do you guys want more or what? I mean, like I said, if you guys have to go, feel free to log off. If you want me to do a few more practices, I can. I will tell you that this does take a little bit of time to kind of like, you know, on your own, go through some more examples. You know, this is your actual assignment is to convert these here. Okay. You want me to do more?
Yeah, I can do like a couple more.
Another couple more? Okay. All right. Let's see. So we'll probably do another, let's do another centimeter one. All right. So if we talk about something measuring 5 centimeters, how many meters is that? So smaller unit, larger unit. So which way are we going to move the decimal place?
Right.
The left.
Left. Oh, yes.
To the left, right? If we're going from smaller to larger, we move it to the left. So we're starting here. And if we talk about centimeters to meters, how many decimal places?
2. 3.
It's centimeters, not millimeters. If this was millimeters, it would be 3, right? Because there are 1,000 millimeters. It's how many?
2.
2. 100 centimeters in a meter. So the answer would be 0.05. Okay. I'll do another one. So something measures 15 millimeters. What is that in centimeters? So
Would
again,
that be 150?
okay, we're going from smaller to larger. But you're right in terms of the number of the units, right? And the factor. But if we have a larger unit here, which way do we have to move the decimal place? Not to the right, right? To where?
Left.
And so if we move it 1 to the left, what would it be? 1.5. Yeah. 1.5 centimeters. Okay.
Okay, I still am a little confused about going from the millimeters to the centimeters.
So what you need to know, right, is how many. So as long as you know that in 1 centimeter, let me write this as a text. Okay, 1 centimeter is equal to 10 millimeters. That's what you need to know, right? You also need to know that 1 meter is equal to 100 centimeters. Okay, and again, there are tables, and there is a table in the lab for next week. If you click on the PDF, you'll see there's actually a table there that shows you these units. But you have to know this stuff first before you can do the conversions, right? So if you know that there are 10 millimeters in a centimeter, no matter what I ask you, you should be able to figure that out, right? So I'll give you another one. And again, I wish I had, and I'll show you guys this. And actually, I think I show you if you watch the lab demo for next week, like I said, things will probably get a little more clear, but I show you guys a ruler, right? So if you think about, and then on there are centimeters. So about like this length is about 12 centimeters or something like that. And then if you look at the little lines that are on the ruler, each one of those is millimeters. So by looking at that and watching the video, it helps you conceptualize a little bit better too. So like I said, you probably, if you haven't really done this, it's going to be confusing at first. So don't think that you're going to kind of get everything all at once. All right. But so as long as you know this, right, let me give you another example. Okay, Michaela. So if we say something is 120 millimeters, how many centimeters? So we're going from smaller to larger, right? So if we go from smaller to larger, it means we have to move our decimal place to the left. In this case, how many decimal places do we move it?
2.
The factor's what?
100. 2.
Millimeters to centimeters, right? Not centimeters to meters. Millimeters to centimeters. How many millimeters are there in a centimeter?
10.
10. So if we talk about a factor of 10, how many places do we move it?
Twice. 2.
Twice.
For 10?
Oh, one.
1. For 100, twice. For 1,000, right? Do we all agree? 10 has 1 0, right? 100, 2 zeros. And then 1,000, 3. So if it's only a factor of 10, it's just one decimal place, okay? So for this, what's our answer then?
12.0 or 12.
Correct. Yeah, 12 or 12.0. Good. All right, well, so now I'm gonna go back and kind of, I guess, maybe not No, probably not.
The way to solve it is by multiplying.
Well, essentially, you're dividing in this case, dividing by 10.
Oh, I'm multiplying, so that's how.
Well, not if you're going this way. If you're going the other way, if I said 12 centimeters, right, is equal to how many millimeters? Now you have a larger unit moving to a smaller unit. The decimal place moves to the right, the number gets bigger, therefore you're multiplying by 10 and you have 120. So when you're moving to the left, you're dividing. When you're moving to the right, you're multiplying. Okay? All those decimal places mean either if you're moving to the left once, it's dividing by 10. If you're moving to the right once, you're multiplying by 10, right? If you move to the left twice, you're dividing by what? When you move your decimal, 100. If you move your decimal place 2 times to the right, you're multiplying by what, Maria?
100.
Yeah, 100, right? If you're going 2 times. Yeah, it's not a trick question. If you go 3 times to the right, what are you multiplying by?
1,000.
1,000, right? If you're going 3 times to the left, you're dividing by 1,000. So again, you can think about it that way, or you can think about it moving the decimal places. If moving the decimal place thing confuses you, think about multiplying by 1,000 or dividing by 1,000, depending on what units you're talking about, okay? So I guess I'll give you maybe just another one there. Oops, I erased that. I probably needed that. Oh well. All right. So if we have 56 centimeters, and we want to know how many millimeters that is. So let's not talk about decimal places. Let's talk about multiplying or dividing. So again, this is a larger unit. This is a smaller unit, right? And if you're trying to get, no, let's not even do that.
Divide by 10.
Why would you divide?
You multiply.
Right? Because remember that analogy. If you're talking about the larger unit versus the smaller unit, right? And we're saying, all right, in 56 centimeters, how many millimeters can you fit? You can fit a whole bunch of millimeters in that centimeter.
Would it be 5.6?
Are you multiplying or dividing? Or going from centimeters to bigger?
It was 5.6. I don't know why.
560.
You're multiplying by 10 or moving your decimal place once to the right. Why? This is a larger unit. This is a smaller unit. It's getting bigger. Again, you're asking, if I have, right, you're saying, I have 56 centimeters. I have 56 of something of this size. I want to know now how many of this size can fit in that 56. It's going to be many more. Do you guys agree? And so if it's more, you got to make that number bigger. Like I said, you may feel confused still. It's okay. You have to kind of work through this. It's something that you sort of have to kind of work through yourself and practice a little more. Like I said, you can bring this up with Katie. She can go over this with you too. Search up like Khan Academy and metric conversions. That might be helpful as well. There's a bunch of kind of other like resources that you guys can use if it's still a little confusing. If it's still a little confusing, it's also okay for now, okay? Like I said, you're gonna do more of it next week as well. So I used to do this all together in one lab and then it was like, oh, so that's why I always separate it out. We get a little exposure to the conversions and then you revisit it again next week when we bring in the microscope as well, okay? It's kind of like a measurement kind of microscope lab. So there's a couple things going on in there. All right. You want me to do more?
Yes, please.
Good. I'll do a couple more and then that's it. Then I'm going to leave you guys to kind of sort of read through this more carefully and just and try to work through it a little bit on your own. Again, however you figure it out, I don't care, right? I'm showing you sort of one method of doing it, maybe two I kind of showed you, but you can really figure it out any way you want. All right, let's go with
Liters to centimeters.
51 milliliters. How many liters?
51 milliliter.
So you have a smaller unit, you're going to a larger. So which way you're going to move your decimal place? Let's establish that first. Or
To
are you
the
going to
left.
The left.
Correct. To the left. The number's going to get smaller, right? All right. And so how much smaller? What factor?
100.
Why? This is milliliters and this is liters, right?
1,000, wouldn't it be?
1,000. The only time we have hundreds is when we're talking about centimeters, right? Centi means 100. So if you're talking about the difference, think about what those prefixes mean. So if you're thinking about a meter as being your base unit, and then you say centimeters, right? It's 100 times smaller, okay? But then the next one in line is milli, so that's 1,000. So whenever you see milli, 1,000, right? 1,000 times smaller of your base unit. So in this case, we're talking about liters because we're talking about volume. So if it's 1,000 times smaller, what do we end up with? What's our final number here?
0.051.
Correct, 0.051. Good. All right. 57 millimeters. I'm going back to the centimeters. Is equal to how many centimeters? So again, this is only the difference between millimeters and centimeters. So what did we say? That's a 7, by the way. How many millimeters are in 1 centimeter? Remember that ruler like this? It's 12 centimeters long, and then how many? Sorry, how many? Who said that? How many millimeters in 1 centimeter?
10.
10, correct. Okay, so what do we got here then? Which way are we moving our decimal place? This is larger, right? So which way?
To the left.
The left, it's gonna get smaller. And how many decimal places? It's 10, right? You guys told me 10, factor of 10. How many decimal places?
1.
Good. 5.7. Okay, all right. You can go the other way. Or one more. 4.8 centimeters is equal to how many millimeters? So we already established this. We know it's a factor of 10, right, guys? In this case,
48.
now, say it louder.
48.
48. You moved it 1 time to the right, or you multiplied by 10. Do you guys agree?
Yeah.
Yep. Okay. If you look down here, just to kind of, just looking at some of those practice problems down there, I'm not going to tell you, I'm not going to do them for you, but if you look down here, right, this is going from nanometers to microns or micrometers. Remember, it's just a factor of 1,000. Okay. So you may have to look up, remember how I kind of wrote out those, I'll do it one more time. Let me just do that one more time. But you can look it up as well, but maybe it's just easier if I sort of, I need the eraser. So there are tables that will outline this, but basically, let me move. Right, remember I wrote this out, guys, and saying, okay, nanometers to micrometers, right? Millimeters. Okay, let me just do it like this, okay? Okay, if you guys look at, why is this in the way? If you look at this right here, right? Nanometers, micrometers, millimeters, meters to kilometers, all of those are kilometers. All of those differ by what factor, guys?
1,000.
1,000, every single one of them. 1,000 going from here, another 1,000 here, another 1,000, another 1,000. Then remember though, we can add in like a little extra one in here, right? And we add in centimeters in there. So centimeters is in between. So again, too, think about this size-wise, right? This is the smallest unit getting larger and larger. And remember, we can add centimeters in between millimeters and meters. Does that help a little bit? Right? So if we add centimeters in here, this, I don't know why this thing can't, oh, there we go. I can move out of my way, right? We would add centimeters in between there, right? And so remember, centimeters, these differ by a factor of 1,000. Remember, there are 100 centimeters in a meter, okay? And there are 10 millimeters in 1 centimeter. Okay, but again, these are all a factor of 1,000. And that's also true if you talk about, you know, right, nanograms, micrograms, it's the same thing, okay? Milligrams, grams, right? And kilograms. You guys all agree these all differ by a factor of 1,000, okay? Well, each one of them. And then same thing again if you do, so again, remember, it's always smallest going to largest, left to right. If you now, because I'll leave this up here as we end here. So then if you go from, you know, I said you're not going to talk about nanoliters. Nobody measures anything in nanoliters because I don't think you can. Microliters. What's next then after microliters? Here. What would be the next largest unit after microliters?
Meters.
And then what? Liters. Okay, so for volume, those are kind of the only three that we use. Again, these all differ by what factor, guys?
1,000.
1,000. Okay. All right, so you guys, so I don't know, hopefully that helps, but really you just need to know this information and then you can answer all of what's those practice problems. That's also, this information that I kind of wrote out here is sort of kind of presented and demonstrated in this little table below here too, just so you guys know. Here, this is kind of, I mean, that's what it's showing you. It's just using different units to show you that same relationship. Okay.
What is the empty spot on the first one?
I don't know why there's an empty spot there, to be honest.
Okay.
That's a good question. I don't know why. Oh, because
The 8 has it too.
yeah, I don't know. I have to look at that a little bit more to see why they're starting with. I guess because then they're not going to go any larger than that, right? This is a liter. They're not going to talk about any unit larger than a liter. This is a kilogram. We're not going to talk about anything larger than a kilogram. Same thing, kilometer. We're not going to talk about anything larger than that. I think that's why. I don't know. So just ignore that. It's something in the way that they're sort of presenting this. But basically what you want to kind of think about is just looking at the relationship between those units that they have sort of comparing on that same line, right? It shows you the factors that they differ by. And it's basically what I just showed you, you know, up here. Let me just write that in too. So then I kind of leave you with it, with that. Okay, that all these are going to differ by a factor of 1,000, except when we throw centimeters in here. All right, so I'm going to leave you guys. Guys, why do I smell something burning? Oh, I'm sorry. I think I saw something outside. So I'll leave you guys with that. If you feel like you need more, just kind of maybe take a break and go back. Like I said, maybe look up Khan Academy or bring this with you to Katie tonight and go through it with her. I'm fine if you even do these problems with her together. That's fine. Okay. So this is the only thing that needs to be submitted for Friday, by Friday. Okay.
All right. Thank you.
All right. Thanks, guys.
Bye-bye.
Bye.
Thank you. Bye.
Bye. I'll stay on
Thank
for a
you.
few more minutes if anyone has anything.
Bye, thank you.
Bye, guys.